Today we're going to be doing binomial probability distribution. So we have a formula here which we use to calculate the probability of an event occurring. Um, and we have our mean, which is this is a mean of success, and this is a mean of failure. Of course, there's only one variance because either way, if you times q in any direction, you still get the same variance or the standard deviation. That won't change. So the mean of failure, it will be the number of the possible x values um, times the probability of failure, and then the probability of success will be given by the mean of success will be given by the and times the probability of success. Okay, so now let's work with an example. So this is our example. In an experiment, 5 animals are given a drug. So you already have given your n value here, 5 animals. 1/5 of all animals given the drug develop a certain symptom. I determine the probability that 2 animals will develop the symptom. So for number one, you have a probability of you want x equates to 2 because they say 2 animals, specific, not more than 2, not less than 2, no, at least 2. It is just 2 animals. So some people try to overcomplicate this question. And then the second part, it says at least 3 animals will develop the symptom. So for at least 3 animals, for number 2, that will be p of x greater and equal to 3. So then that's what you're dealing with, greater than equal to. Well, as soon as you see that word, at least. So now let's work with our things here. So just something to note, at least
means
greater or equal to. And then, so now, okay, we have our probability, which is that one. So we know that we have 5 animals that are being tested. So that's n is 5. And then we have 2 here. And then the probability of success. The probability of success is given in the statement. Most people will miss it, but do not. So this is the 1/5 of all the animals given the drug will develop a symptom. So the probability of success is the one that's given on the statement, number one. And developing a symptom, it's not a failure, it's success. So basically, it means that 1/5, that's the p value, and then this is to raise to the power of 2. Just remember like this: it raises to the power of 2, and to get the other one will be 4/5. That means that you have to raise this one to the power of 3 because this number and that number, they have to be equal to this number. So 2 plus 3 is 5. So which is basically 5 minus 2. That's the formula there. If you look up here, that's how we wrote it. Okay, so now let's punch this on a calculator. So this is 5. Let me just this is 5 combination 2, and then it is times that 1/5, which is 0.2, 0.2 to the power of 2, and then it's 4/5, which is 0.8, 0.8. By the way, how do you get failure? It's failure q. It's always equals to p of, it's 1 minus p. So that's how you get q. I always forget to just mention that because sometimes people get lost. Why is it like that? So how do you do 5 combination 2? It is 5 shift division. You get a c there, and then 2, and then equals to, then that will give you 10. And then this is times 0.2 squared equates to 0.04, and then this is to the power of 3, and then it's 0.8 to the power of 3, That's 0.512. So you times everything together. So that will be 0.512 times 0.04 times 10. So that should be that will give you 0.2048, which is that's basically 28.48. 0.48%. Okay, now let's work with this one. This one is very interesting because basically you need to do so basically it means that you have to add probability of it's P of x equals to 4. Oh, not forgetting 3. 3 plus P of x equals to 4 or plus P of x equals to 5. So note that sometimes you have more than those things because now the last one is the fifth one. So it goes on to like, whatever. So now you can also rewrite this as 1 minus P of x less than 3, right? Which is 1 minus open bracket P of x equates to 0. So that's the first one. X equals to 0, and then it is plus P of x equates to 1, and then it's plus P of x equates to 2. So note that now this is essentially more work. This is more work than this part. So it's basically better to take the top part, then work with it. So, but know that next time you can also do this, which is the complement of this one. So let's just use the first part. So it is for the first part we have 5 and 3. We have 0.2 to the power of 3, and then we have times 0.8, 0.8, and then this is to the power of 2, and then it's plus 5 combination 4. This is 0.2 to the power of 4, and then this is 0.8 to the power of 1, and this is plus 5 combination 5, which is 0.2 to the power of 5, and then this is will be 0 to the power of 1, this part 0.8 to the power of 0, sorry. So that will just become 1. So you just can just now we have these 3 calculations. So we already punched in those numbers. So we just need to add them. So we just need to add 0.0512 plus 0.064 plus 0.003, 0.05792, which is 5.792%. Okay, so that's the final answer there. That's the probability of getting 3 or more, or at least 3 who develop the symptom. So now that's all about that's all about binomial distribution. So the next video will be on Poisson distribution. So stay tuned. Don't forget to subscribe and like the video. Thank you.